Okay, so today we're going to be learning how to design a active versus passive high-pass filter, and we're team 15. A passive high-pass filter is a circuit that allows only signals above its cutoff frequency to pass, while an active high-pass filter is the same thing, but it adds an operational amplifier to the circuit, and the purpose of the op-amp is to provide amplification and gain control. We came up with a 6-step process to solve design problems. Some rules are to first determine if the circuit will be active or passive and make a template of the circuit. Rule 2 is to choose any capacitor value. Rule 3 is using the given cutoff frequency, solve for R1 and solve for the R1 resistor value. Rule 4 is using the V in and V out, solve for the gain. And Rule 5 is to use the inverting or non-inverting gain equation to solve for R2 and RF. But for Rule 4 and 5, that's only required for the active high-pass filter, not the passive. And 6 is to draw out the circuit. Okay, so here we're going to design a passive high-pass filter example. And the question is to design a high-pass filter with cutoff frequency FC equals to 1 kilohertz, let V in equals to 10 volts and V out equal to 100 volts. Identify the resistor and capacitor values. So the template we came up for this circuit was this, and we're going to solve for the C1 and R1 values. And notice that there's no op-amp because this is a passive high-pass filter. So to solve this, we have this cutoff frequency equation, and we're going to solve for R and just make up a C value, and it can be anything we want, but to make it easy, we're going to make C equal to 1 microfarads. And to solve for R, we have our FC value and we have our C value, so we can plug these values in. So FC is equal to 1 times 10 to the 3 hertz is equal to 1 over 2 pi R times 1 times 10 to the minus 6 farads. And when we do this, R equals to 159.15 ohms. And then after this, we can plug in the capacitor value and the resistor value into here and get C1 is equal to 1 microfarads and R is equal to 159.15 ohms. And that's how you design a passive high-pass filter. Next, we're going to be doing an example of designing an active high-pass filter, and the question is to design a high-pass filter with cutoff frequency FC equals to 1 kilohertz, let V in equals to 10 volts with a frequency of 5 kilohertz, and V out equal to 100 volts with a frequency of 5 kilohertz, and to identify all the resistor and capacitor values. This is the template we came up with for this question, and the first thing we're going to do is solve for R. This would be R1, using the cutoff frequency and the capacitor value, and similar to the first one, to make it easy, we're just going to make C equal to 1 microfarad, and we have our FC value and our C value now, so we can solve for R. So 1 kilohertz is equal to 1 over 2 pi R1 times 1 times 10 to the negative 6 farads. And here we get R1 is equal to 159.15 ohms. So now that we've solved for our R1 value, we can solve for gain. And in this equation, gain is AF. And we have all the values we need, with V out being 100 volts, V in being 10 volts, F being 5 kilohertz, and FC being 1 kilohertz. So if we plug in all those values into this equation, we can solve for gain. So 100 volts over 10 volts equals to AF times 5 times 10 to the 3 hertz over 1 times 10 to the 3 hertz over the square root of 1 plus 5 times 10 to the 3 hertz over 1 times 10 to the 3 hertz squared. And from this, we get AF is equal to 10.198, which is our gain value. So since the voltage supply is going into the positive terminal, we know that this is a non-inverting op-amp circuit, and because of that, we'll use this gain equation to solve for the RF and R2 values. And we know that the gain is 10.198 because we just solved for it. So if we plug that into this equation, we get that the ratio of RF over R2 is equal to 9.198. And so for this, we can just plug in any values we want that will give us this 9.198 value. So RF can equal 9.198 ohms, and R2 can equal just 1 ohms because when you divide those, you just get 9.198, which is the gain. And from here, all you have to do is plug in these values into the circuit and you're done. So RF is equal to 9.198 ohms, R2 is equal to 1 ohm, the capacitor was equal to 1 microfarads, and R1 was equal to 159.15 ohms. And that's how you take a problem and design a passive or active high-pass filter. Thank you.